Have you ever wondered what makes a compass needle point north? Or how MRI machines can see inside your body without any radiation? The answer lies in one of nature's most fundamental and invisible forces: magnetic fields. This is Physics in Motion YouTube channel, and today we're going to make the invisible visible. Let's start with something you've definitely seen before: a simple bar magnet. You know, those red and blue things you probably played with as a kid. But here's the thing: there's an invisible force field surrounding this magnet right now, and we're about to see it. Watch this. When we sprinkle tiny iron filings around our magnet, something absolutely magical happens. Those little pieces of iron become tiny compasses themselves, aligning with the invisible field lines. Look at that. We've just revealed the hidden architecture of the magnetic field. These elegant curves show us not just where the field exists, but also its direction and strength at every single point in space. The closer the lines, the stronger the field. But wait, magnetic fields aren't just flat, two-dimensional patterns. They exist in full three-dimensional space all around us. Imagine every point in this 3D grid has a tiny arrow showing the magnetic field's direction and strength. This is what physicists call a vector field, and it's surrounding us right now, completely invisible to our eyes. Now here's where things get really interesting. What happens when we fire a charged particle, like an electron, through this magnetic field? Watch carefully. The particle doesn't just fly straight through. Instead, it gets deflected in a beautiful spiral path. This is called the Lorentz Force, and it's one of the most important forces in physics. The magnetic field grabs that charge moving and curves its path. The faster it moves, the tighter the curve. It's like the field is sculpting the particle's trajectory in real time. But how do we predict which direction this force will push our particle? Physicists have a clever trick called the right-hand rule. Here's how it works. Point your fingers in the direction of the particle's velocity. Now curl them toward the magnetic field direction, and your thumb automatically points in the direction of the force. It's like nature gave us a built-in calculator in our hands. This simple rule unlocks the mathematics of electromagnetic forces: F equals Q times V cross B. These aren't just abstract physics concepts. Magnetic fields are everywhere in your daily life. That vibration in your smartphone, that's a tiny electric motor using magnetic forces. Getting an MRI scan, you're lying inside a magnetic field 30,000 times stronger than Earth's. And those massive particle accelerators that discovered the Higgs boson, they use supermagnets to bend particles at nearly the speed of light. From the smallest motor to the largest machines on Earth, it's all magnetic fields in action. So remember this: magnetic fields are invisible highways of force that surround magnets and moving electric charges. They exist in three dimensions, they have direction and strength, and they can bend the path of anything with electric charge. Understanding magnetic fields isn't just physics, it's understanding one of the fundamental forces that shapes our universe. And we've only scratched the surface. If you want to dive deeper into the physics that powers our world, hit that subscribe button and ring the notification bell. Trust me, we're just getting started with the amazing physics all around us.